Good morning friends, welcome back again in the our next video lecture series of our paper second semester third, that is organic section, aromatic, carboxylic acids and sulfonic acids. So in the next part of this video we are dealing with the three monocarboxylic acids, their preparation methods and chemical reactions of these three acid part. Now let us see the second acid, that is aromatic acid, naming Anthranilic acid or Ortho Amino Benzoic acid. So we have seen the methods of preparations and chemical reactions of benzoic acid. Now the next acid is Anthranilic acid or Ortho Amino Benzoic acid. Here when we consider benzoic acid, just one NH2 group is attached in this next acid part. Now let us see the chemical reactions or methods of preparations of these three acids. Now first one is Anthranilic acid or Ortho Amino Benzoic acid. So when we consider the different isomers of this Anthranilic acid, here we are considering, or the importance is given to the ortho isomer part. Now the ortho isomer part, when we consider, so preparation of the anthranilic acid, that is having two methods of preparations in our syllabus. One is from orthonitrotoluene and another is from phthalimide. So here the preparation method of orthonitrotoluene and phthalimide is given. Now so it may be prepared by reduction of orthonitrobenzoic acid or by internal oxidation of orthonitrotoluene just by heating with alcoholic sodium hydroxide solution. Means when we treat orthonitrotoluene in presence of alcoholic NaOH, so we get anthranilic acid, just NH2 group is introduced in the and COH group is also formed just by internal oxidation of orthonitrotoluene. Another method is, when we consider the another method, that is from phthalimide preparation. So first we can obtain phthalimide by the phthalic acid source, and then phthalimide can be treated with the oxidation of phthalimide with aqueous sodium hydroxide and sodium hydroxide, just as using the Hoffman reaction. So phthalimide is giving anthranilic acid. Now sodium hypochlorite can also be used for the preparation of this anthranilic acid. Considering the properties and uses, so it is anthranilic acid is white solid which is having melting point 145 degrees centigrade, having sweet taste, soluble in water, alcohol and ether. On heating, it loses carbon dioxide molecule to give aniline part. It undergoes the usual reactions of an amine and an acid. It finds use in the manufacture of indigotine. Now after the preparation and properties of physical properties, let us go on or move on to the chemical reactions of these anthranilic acid. In syllabus we are having anthranilic acid three treatment part, that is using nitrous acid, then action of heat, and then action of acetyl chloride or acetic anhydride part. Now let us see the first part from the anthranilic acid. Now anthranilic acid, when we treat with the NaNO2 solution and HCl at 0 degree centigrade, we are getting the salicylic acid, means ortho orthohydroxybenzoic acid. Orthohydroxybenzoic acid, also named as salicylic acid. So anthranilic acid, when we treat with nitrous acid, it is giving the salicylic acid part after diazonium salt preparation. Now action of heat. Another reaction is when we heat this ortho-amino benzoic acid or anthranilic acid, it undergoes decarboxylation reaction, so forming just aniline part. Another reaction of this anthranilic acid is action of acetyl chloride or acetic anhydride. So when we treat anthranilic acid with this acetyl chloride or acetic anhydride, we are getting the N-acetyl ortho-amino benzoic acid. So it is written, so it is having benzoic acid part and NHCOCH3 part. So that is N-acetyl ortho benzoic acid part. Now there is another part. Considering the uses of this anthranilic acid, it can be used in the synthesis of various dyes. Another part of the acid is salicylic acid, orthohydroxybenzoic acid. Of the three hydroxybenzoic acids, here also orthoisomer is considered as an important one. Orthohydroxybenzoic acid, or we can say salicylic acid. Salicylic acid is, that is, salicylic acid can be prepared by two methods, just by using phenol and by Riemann-Tiemann reaction. When we treat this phenol in presence of NaOH, we get sodium phenoxide, and when we treat with the carbon dioxide at 125 degrees centigrade under pressure, so we call it as the Kolff reaction. Sodium phenoxide can be formed from the phenol part. So this sodium phenoxide, on treating with the carbon dioxide at 6 atmospheric pressure at 125 degrees centigrade, we get ortho hydroxybenzoic acid or salicylic acid. So the alkali part is neutralized by acidification process. Now after this, the next reaction is Riemann-Tiemann reaction. In the first preparation, means using phenol and using CO2, that is Kolff reaction. Another part is Riemann-Tiemann reaction, when we use the same reagent phenol and just treat with carbon tetrachloride, so we get salicylic acid in the Riemann-Tiemann reaction part. Now considering the properties of these antranilic salicylic acid, here salicylic acid is also a colorless solid having melting point 159 degrees centigrade. It is insoluble in cold water but dissolves in hot water, ethanol and ether. It sublimes below its melting point and is steam volatile. It is stronger acid than benzoic acid. Salicylic acid behaves as an acid and a phenol. Like phenols, it gives violet coloration with ferrichloride solution. Now the another part of the salicylic acid, that is the preparation. After preparation properties, there are chemical reaction part. Here are around 3 to 4 reactions are there. 4 reactions are given in the syllabus part. One is bromination, then nitration, decarboxylation and reaction with zinc dust. Now let us see the first reaction part from the chemical reactions. Means when we use salicylic acid and treat it with bromine part, we get the tri-substituted product of this salicylic acid, that is ortho hydroxybenzoic acid. So 2,4,6 tribromophenol is formed when we treat salicylic acid with bromine. So 2,4,6 tri-substitution is there. So COH group is replaced by bromine atom. Now after this, second reaction is nitration. Nitration reaction means salicylic acid, when we treat with fuming nitric acid, we get the product again, the nitro substituted product, that is 2,4,6 trinitrophenol. 2,4,6 trinitrophenol can be also called as picric acid. There is another reaction, the carboxylation reaction, when salicylic acid is treated with soda lime, that is a combination of NaOH and calcium oxide. So it is giving the phenol part, phenol plus Na2CO3. The reaction of salicylic acid with zinc, it gives reduction product, means OH is replaced or OH is removed from the salicylic acid part. Here we get benzoic acid. Benzoic acid can be prepared from the salicylic acid just by using zinc dust. Now here the salicylic acid part is completed. Now the another part of the acid, aromatic carboxylic acid part, is phthalic acid. Here it is given benzene dicarboxylic acid, means phthalic acid is an example of having two COH groups in its ring, that is phthalic acid means dicarboxylic acid example. Other dicarboxylic acid, when ortho substituted carboxylic acid is there, we call it as phthalic acid. When meta and para are there, so there are having other names, isophthalic acid and terephthalic acid. Now we are dealing with the first one, that is phthalic acid part. Phthalic acid, we are having two methods of preparations. One is from orthoxylene and another by using naphthalene part. Now when we consider the preparation part of phthalic acid, we have to remember two carboxylic acid attached to the benzene ring. When we consider the preparation part, so we can use orthoxylene, and when we oxidize orthoxylene by using potassium permanganate, we get phthalic acid. Another source is by using naphthalene. When naphthalene vapor and oxygen or air over vanadium pentoxide catalyst at 500 degrees centigrade is used, phthalic anhydride is first formed, which on hydrolysis yields phthalic acid. Means there are two methods of preparations where oxidation process is carried out for the preparation of phthalic acid. Now consider the properties part. Now considering the physical properties of phthalic acid. Phthalic acid is a colorless solid having melting point 231 degrees centigrade, soluble in hot water. It gives following reactions, means when we consider the syllabus part, we are having three reactions, that is action of heat, action of PCl5 and action of ethanol. Now consider the first reaction, that is action of heat. When the phthalic acid is heated at 160 degrees centigrade, it loses a molecule of water to form phthalic anhydride. So only phthalic acid forms anhydride, while the meta and para isomers fail to do so. Means phthalic anhydride can be prepared from phthalic acid just by heating or the action of heat at 160 degrees centigrade. Now another reaction is reaction with PCl5. When we treat PCl5 and phthalic acid, we get phthaloyl chloride. Here COCl part, COCl part is shown, that is COCl, 2-COCl means 2 COOH group are replaced by acetyl group plus POCl3 plus HCl part. Another reaction part, that is ester formation, means when we treat this acid with alcohol part, that is ethanol part, we get diethyl phthalate, that is the C2H5COO group, that is diethyl part is introduced. Or we can say, when we consider COH group as a functional group, then hydrogen is replaced by ethyl group and 2 molecules of hydrogens of carboxylic acids are replaced by 2 ethyl group. In the next part, we are going to deal with the aromatic sulfonic acid. So let us consider the next part in the next video. So thank you.